Welcome to the video series on ABB AC500 PLCs and HMIs. Well, in this video we will describe the steps involved in establishing a PROFINET I/O connection with an AC500 controller. Upon completing this video, you will be able to understand the configuration and programming of an I/O system using the PROFINET fieldbus technology from ABB AC500. The use of online PROFINET diagnostic functions are also briefly discussed. As a first step, we would discuss the various possible network topologies supported in PROFINET I/O communication. The picture on the screen shows what is called a line topology. This is a well-known topology used in automation applications. PROFINET modules are equipped with integrated Ethernet switches that facilitates the realization of this line topology. Herein we see star topology, which is suitable for cases where several network nodes are positioned close to each other. For example, in a single cabinet. What we see now is called the tree topology. Well, a tree topology is basically a combination of several star networks, typically meant for a large automation plant grouped into different manufacturing islands. In this example, the interesting point is the routing function. That is, an engineering station connected to a switch in TCP/IP protocol could in turn download a program to the AC500 controller over the PROFINET network with appropriate settings. Now we briefly talk about the different PROFINET modules offered from ABB AC500. Firstly, the PROFINET I/O controller module CM579PNIO. This module has some interesting features like built-in Ethernet switch with 2 ports and supports a data transfer rate of 100 Mbps in full duplex mode. Connection of up to 128 PROFINET I/O devices possible with this module. Bicolored LEDs on the module gives information about the running and diagnostic statuses. The 2 rotary switches are reserved for future usage. What is seen now on the screen is the different PROFINET I/O bus modules. According to their specification, they come out with different types of built-in IOs and protocols. Each I/O device could handle up to 10 I/O modules. A sample hardware connectivity is shown on the screen, in which a CM579 PROFINET I/O controller is connected to one CI502 I/O device. This I/O device is further expanded with a DI524 digital input module. Now let's have a look at the configuration steps. In the context of PROFINET I/O communication, the I/O controller and I/O device are referred as master and slave. Inside the Control Builder Plus project, we need to integrate the PROFINET I/O master under the Communication Modules option, with a corresponding slave module. Then the I/O module is to be added, as seen in the video. We need to set the IP address, subnet mask and station name for the PROFINET I/O master. The IP address range of the slaves is also set here. Based on the I/O master IP address, the slave's IP address range is automatically set by the software. This could be changed manually if needed. Now open the Codesys instance and download a blank project into the CPU. This download is needed to browse the slaves to read out their name and IP address. In order to set the slave station name and IP address, one must go online with necessary communication driver. Here in this example the address set on the slave module is 02 and hence the name should be CI502-PN-02. Customized name setting is also possible. The CI502 slave comes with 8 digital configurable inputs and outputs. Those I/O signals that need to be used in the program must be mapped with suitable names. In this example we will use the first digital output channel of the CI502 module and the first input channel of the DI524 module, to demonstrate the data transfer between two PROFINET I/O devices. I/O mapping could be done while being online with the controller and offline. When you are online with the controller, you could see the rounded blue arrows. Now let us test the configuration using a pre-created sample logic by opening the code.sys instance. If we open the folder Global Variables and its subfolders, we are able to see the mapped input and output variables. Inside the PLU tab, we had written a one-line structure text program for the assignment of the input status to the output. That is, reading the DI524 input status and assigning it to the output channel in the CI502 module. To test this program we must compile and download it to the controller. As you could see from the screen, the program is working as expected while the controller is in run mode. Let us now see the PROFINET diagnostic feature available in Control Builder Plus to troubleshoot the communication failures. For this we need to log into the CPU first and then click on the CM579 PNIO Master tab. Once this is done, we are able to see some diagnostic statuses pertaining to the PROFINET Master module like List of slaves, Common Status Block, Firmware Identification and NetExstack Task Info. Highlighting each of these status tab will further display more details on the error or status messages. Similarly, we are also able to see the PROFINET slave diagnostic data, just by clicking on the CI502 PNIO tab. Here we see the PROFINET slave node information and firmware identification details. Well, in this case we could see the node status indicator being green, meaning that the slave is working fine.
Thank you for attending this video. If you want to learn more about AC500 range, please use the following link and contact the ABB sales department of your country. Or if you need support while configuring and programming of your AC500 system, you can contact our helpline support. For general comments and questions about this video, don't hesitate to contact us.